It's not particularly secret that I really, really like TypeScript. It made me go from hating web development to enjoying it quite a lot. It's a great language. Well, in some ways, yes. In others, no. TypeScript is still stuck with a lot of the baggage of JavaScript, but JavaScript's also the most prominent language in the world. It's super easy to run, it works everywhere, and there's a crazy ecosystem of tools. TypeScript has helped bridge a lot of the gap and make JavaScript way, way easier to work with and use reliably, because JavaScript does not have the affordances many other languages do around correctness and guarantees that things are going to do what they're supposed to do. TypeScript was built because Microsoft wanted to use JavaScript at Microsoft scale, which might sound like nonsense, but it does make sense when you realize how many millions of lines of code Microsoft puts out every single week. If your systems aren't built for correctness, your systems are going to collapse under the weight of that type of shipping. And TypeScript was built by the creators of C# in order to try and solve those problems. At first, it didn't seem like it made a lot of sense, but then Angular adopted it from Google. Yes, Google adopted TypeScript before Microsoft had meaningfully done the same thing. That caused the whole world to wake up to its powers, and eventually we ended up where we are now, where the vast, vast majority of web code is written in TypeScript using packages that were written in TypeScript too. So where does that put us today? Seems like this is solved, right? No. TypeScript's been an evolving language in Target for quite a long time now, and it's made a ton of progress with everything from performance in the compiler to features to just following standards. But it has a lot of issues too. Things like the default setup not being strict at all because it doesn't have the strict mode on, things like the performance not being great for large code bases, weird rules and inference, and just strange behaviors around recursive type definitions. TypeScript is far from perfect, even within the confines of it being a JavaScript wrapper effectively, but the TypeScript team is aware and they're trying to fix it. They've been publishing awesome blog posts throughout all of this that I want to take some time to go through with y'all. From the progress on TypeScript 7, which might confuse you because we're currently on 5, hopefully the fact that TypeScript 6 is now in beta makes it a little easier to understand where we're going. The roadmap from 5 to 6 to 7 is a little bit chaotic, but what it gets us is magical. We're going to have a way faster and more reliable TypeScript experience, and our agents shouldn't have to care at all. While I have made a lot of money writing TypeScript, the TypeScript and Microsoft teams do not pay me a cent. The only people paying me for this video are today's sponsor. People say the hard things in software dev are naming things, caching, and off by one errors, but they're wrong. The actual hard things are auth, payments, and secure data. What if I told you today's sponsor helps with all of those? Clerk has changed the way I build applications. Whenever I'm not using it, I feel the pain. Their DX is still best in class, not just for humans, by the way, for agents too. I had a monorepo with a web app and a mobile app that I wanted to get set up with auth because I was just testing this out initially. I didn't think I'd be able to do it, but just as a Hail Mary, I threw Opus 4.5 the instruction of adding Clerk to the project, and it did it correctly across Convex, across the web app, and across the mobile app in one shot. It was insane, but it is that easy to set up. And now that they have subscriptions built in, it's even crazier. Through the dashboard, you can set up everything you need to actually charge users for your service. So Clerk is the pieces that I find missing the majority of the time that I am vibe coding apps. It's made it so much easier to actually release the things that I'm building. In a world where everybody's services are doing inference, you might want to bring API key support to your service. Doing that in a secure way is really, really hard. Well, it was, but if you're using Clerk, it no longer is. They set up multi-tenant API key functionality so it's easy for users to bring their own keys to use for different things. It is just provided in their provided UI. Since they already have the organization component, the user component, and all of that, they can just add a little API key section for you and let your users configure all of that. They even have a API keys component that you can render other places in the UI if you want to put this in the dashboard somewhere. Clerk is just so practical that it's hard to look other places. I highly recommend checking them out at soydev.link/clerk. It's time to talk about the future of TypeScript. I think it's important to understand a bit about the past and how we got here in the first place, though. Because remember, the original role of TypeScript was to take these giant JavaScript code bases and make them a little easier to work with at companies of large sizes. So if you're Microsoft, maybe most of your stuff is built for Windows and native apps, but you probably need to have some websites. And if those websites start getting big, maybe you put a lot of work into the web version of, I don't know, Outlook. Making sure changes in one place don't break things in other places is essential. And TypeScript was really built to solve that problem. TypeScript was built to make changes in one place, not break things in other places. And it did a great job at that. But there's a weird thing that happens when you fix a problem in a universal technology. Let's draw out a spectrum. Let's say that before TypeScript, if you split all apps up, that JavaScript would work for the apps that are to the left of here. So JS is fine, is this area here. And here you need a real language. As much as I love the JavaScript and the web ecosystem, The harsh reality is that this little area here is pretty real in terms of like what you were able to do before. Because for lots of reasons, be it the performance of JavaScript runtimes, the performance of the computers that we were using, the ability to distribute JavaScript, the ability to run it on the server, which did not exist at all at the time, and your ability to trust the code that you're building and shipping, all of that was relatively low with JavaScript. And if you were building anything meaningfully complex that needed meaningful performance or worked outside of the browser at all, JavaScript just wasn't an option. But we started to solve some of those problems. The V8 engine in Chrome got so good that suddenly JavaScript was performing pretty well. Things like Node took that performance and brought it to the server so you could run Node outside of the browser. Things like Electron made it easier to use JavaScript to build real-feeling desktop applications. And then TypeScript, which made those reliability guarantees much more consistent and made it possible to trust the code you're writing in JavaScript in ways you never could have before. Obviously, there are things like how much performance is improved on the computers we're using every day as well. RAM being, at least for a little bit, more accessible. Sadly, that's changed, but you get the point. JavaScript became a more and more usable language, a more serious language, a more compelling option. And TypeScript is just one of the parts of that. But it really feels like TypeScript shifted this line a ton, where the majority of apps not only could be written with TypeScript, but I would argue probably should be. Like this whole area here, at the very least, is fully reasonable to be using TypeScript for. Almost every time I've seen someone insist that TypeScript cannot do this thing, I've looked into it and there is some level of just fundamental misunderstanding they have that makes them feel that way. And now we're in a world where the vast majority of projects are totally fine with TypeScript, but there are some places that just need native perf. You know, with something like Go or Rust or C or C++. There are still things that need that. I would argue it's fewer and fewer by the day. And there's also tools like Bun or even just manually writing C++ shims for Node that allow you to get the native performance for the things you do need it for. But the point I'm trying to make here is that over time, all of these things have pushed this bar to the right as more and more of the problems that made JavaScript and TypeScript unusable for most applications have been eliminated time and time again. But the point I'm trying to make specifically is that when you do something like TypeScript, it feels like you're solving the problems in this small section because you are. You're making some people who are stuck in this corner feel less stuck. But the same thing that makes using TypeScript in this little piece so useful result in the size of this piece growing inherently. And that's what happens with TypeScript. Not only is TypeScript making our web apps more type safe, it's letting us bring JavaScript outside of the browser. It's letting us do crazy things with our type systems like full stack type safety from server to client. It's letting us build type systems that encapsulate our entire code bases. Hell, it's letting us do insane things like rebuilding all of Doom as TypeScript types. And to be clear, I'm not saying that they rewrote Doom in TypeScript. I'm saying they used TypeScript's type system that happens to be Turing complete to generate frames of Doom. One of the craziest projects I've ever seen. Like, because TypeScript is so good and solved the problems we had in the browser, it has now pushed us way outside of the browser to do things that the TypeScript team could never have imagined. But this means we now have a new problem. TypeScript solved the problems we had building small web apps with JavaScript, but now we have gigantic TypeScript apps. And as a result, TypeScript is slow. Not that the language is slow. V8 helps prevent that, but TypeScript compilation is slow. Actually building your TypeScript app and checking all of the types and making sure everything is correct before you put out the JavaScript you actually run, that is hard to do. The majority of the TypeScript type checking is a single 55,000 line file that causes GitHub to error out when you try to view it. 55,000 lines of TypeScript. This is the majority of the language and the things that we know and care about that we call TypeScript. It is this single giant file that breaks most of the things you try to open it in. It is a 3 megabyte file of text. That is the TypeScript that we use and build on top of every single day. TypeScript is written in TypeScript for a ton of reasons. The main one that matters is that TypeScript is built on JavaScript, and JavaScript is a very, I'll use the word flexible language. JavaScript's quirks are hard to model in other things. Since TypeScript is written in TypeScript, it's much easier to model the type system because you have JavaScript resolving it. But JavaScript's a terrible language for writing compilers in. JavaScript's strengths around its event loop are great for weird async workloads like requests coming in, database calls being waited for, and additional requests being responded to in that time. JS is great at those things. It is not good at these types of fixed, top to bottom workflows like a compiler. It just isn't good at that. There are other languages that are, and that's a big part of what's happening now. Put it simply, TypeScript itself is too big now, TypeScript code bases are too big now, and TypeScript is too slow, specifically for type checking. These problems did not matter before when we were just building these small web apps. Now they matter a lot. Back when I was at Twitch, we rebuilt the whole web app in TypeScript and React, and even just 2 years in, it got to the point where it was taking 5 minutes from when you ran npm run dev to when you could actually see the dev environment. There have been a lot of developments to help with those types of things, but the type checker is still slow. And that is a huge part of what Microsoft is trying to fix now. I'll emphasize the things that they're thinking about, and then we'll dive into all the coverage. The first thing is better defaults for humans and agents. Then there is type checking, performance. And one last really important one, better information when things go wrong. This is stuff like your compiler errors, your traces, all of the things that are necessary for either a human or an agent to identify when your types are bad. And this is why the recent changes are happening. You might have already heard about this. If not, I'm about to blow up your entire brain. TypeScript is being ported. Do you know where? To Go. Go is an interesting choice. I covered this in my video. I do think it's the right choice because Go is relatively flexible. And the biggest negative to Go versus Rust, other than how awful the type system is the garbage collector. Garbage collection can make real-time performance rough because you never know when you're going to hit a garbage collection pass and might have to not get the next request out so much. If you write code in Rust and it takes 1 millisecond to respond, it will always take 1 millisecond to respond. If you write the same code in Go and it takes 1 millisecond to respond, it might randomly sometimes take 10 milliseconds because the garbage collector had to spin up and clean up everything in memory. Do you know who doesn't care about those random spikes? Compilers. Compilers don't care about the exact frame the thing is done on. Compilers care about doing things as efficiently as possible, reasonably speaking. And if it has to do some garbage collection throughout, who fucking cares? Who cares at all? It doesn't matter. Go, for that reason, is great. Go's flexibility is also great because JavaScript is a bad language and Go will not be as strict about how you work with it. And they are now very deep in this port. So what's this TypeScript 5, 6, 7 stuff? Well, now that my comment section is flooded with 6, 7, I'll break it down. TypeScript 6 is the clean shit up version, and TypeScript 7 is the Go version. What do I mean by this? Well, the nature of any tool, especially something like TypeScript, is that there's a ton of tech debt, a ton of questionable things that happened in the past that are still being maintained. They've historically maintained all of this, but now that they're building a fresh start for TypeScript that's meant to be fully identically compatible with the Go version, maintaining both in parallel sucks. And the more they can do to trim down the weird shit in TypeScript, the easier it is to keep these two things aligned. So a lot of the TypeScript 6 efforts are trying to get TypeScript aligned with TypeScript Go. Because, spoiler, TypeScript Go is already out and entirely usable. We're using it for a ton of our projects already. It's really good. It has its issues, it randomly crashes and has memory leaks here and there, but overall it is significantly more performant, like 10 plus times more performant. But there's already a decent bit of drift between TypeScript Go and TypeScript 5. And 6 is meant to close a lot of that drift while also doing a bunch of small things that I personally have wanted for a long time. And the goal is to get TypeScript 6 to a point where it is so well aligned with the Go version that in not much time, hopefully by end of this year, they'll be able to deprecate it and go all in on the Go version with TypeScript 7 onwards. And this is why I'm so excited for the TypeScript 6 beta. TypeScript 6 is a unique release in that we intend for it to be the last release based on the current JavaScript codebase. As they announced last year, they are working on a new codebase for the TypeScript compiler and language service written in Go that takes advantage of the speed of native code and shared memory multithreading. This is another big piece with why Go and not Rust. Having multiple threads editing the same memory at the same time is a thing Rust will fight you super hard on. Go doesn't give a fuck. Very helpful for what they're doing. This new codebase will be the foundation of TypeScript 7 and beyond. TypeScript 6 will be the immediate precursor to that release, and in many ways, it will act as the bridge between 5.9 and 7. As such, most changes in TypeScript 6 are meant to help align and prepare for adopting 7. With that said, there are some new features and improvements that are not just about alignment. Let's take a look at some of the highlights of this release. No way, this changes from me. Whew. Oh man, that is wild. I did not know this was in here until now. That is crazy. Theo from the future here. That was a painful deep dive. I was wrong. I do not have the thing I wanted. I, once again, know too much about TypeScript and am going mad. I am sad. I am heartbroken. And I don't want to waste your time. So if you're curious what the hell I just went through, we will continue with that. Feel free to watch my suffering or skip it. Whatever you prefer. Okay, context on this one. I need to do a short rant. I am so sorry, but you guys claim you want more of these nerd out videos. You're getting a fucking nerdy one here. Let's do it. This one goes back to 2023 when I was first working on Upload Thing. Upload Thing was meant to heavily lean into TypeScript so that we could configure a type-safe file uploading solution that had everything from the return types from the API to the things being passed to your authentication, authorization, all of that be fully type-safe. The structure I wanted for this is that you had an object that had the function for what you would expect the user to send, verify, and then a different thing that you would return. But there was a problem here. Let's see if I can hop over to the TS play that I actually originally made here. So here we have this type, config. It has two sub functions. These are like keys in the object. The function here takes in request, and it returns promise of type T. Then there's another function in here that has a response, and this has metadata of type T. The reason we did things this way in Upload Things, we wanted to take the input function and pass whatever you did in it to the next function, but we wanted the type here to match, and we could not get it to do this. It was our understanding with how TypeScript worked that I should be able to define a function here that has some type in it. It returns ID as type number, and response should know that it is type number. So here's where things get really weird. We manually specify that request is of type request on this input function here. But if we remove that, it can correctly infer that request is type request. So it knows that. We didn't hard code it. But if we hard code it, it knows that this has number. If we don't include that, it fails to match the type of this properly, and it breaks the return type of the second thing. The type of this function did not change, to be very clear. Adding :request here does not change anything. The type of this is exactly the same, but an internal mapping that bound this to this through TypeScript's inference layer caused that to break, even though it knows that request is type request. Nothing changed here, or here, but because of how the generics work of defined functions within an object of this, it failed. This made it so we couldn't use the pattern you're seeing here for Upload Thing. We had to go with builder pattern instead. And it pissed me off a lot. And I was not the only one who was pissed. When I showed this to Trash, he was like the TypeScript wizard in my circle at the time. He concluded it had to be a bug. It kind of felt like one. Tagged it in Darist, tagged in Matt Pocock, made an even simpler version here. If you define it not as an arrow function, but as a standard function definition, it would break. Fixing this would be over my head since this, if I recall, would have to change how the inference for reverse map types are made in the first place. It seems too fundamental to touch this by me. And there was a lot of back and forth. He actually got a PR up that fixed it a while ago, but it looks like it might be fixed now. Yeah, and here it said if you wrote method syntax instead, it would break. Error, Y is of type unknown. Yep, this is the exact fucking problem. No way. No fucking way. Let's switch over to the nightly. No, it's still broken. Maybe if I define it like this. No. Man, I was so excited they might have fixed that. Oh. So it works for intra-function definitions. So if I understand... Oh, no, this should be that. This is a fake function helper. This should do it. Oh, I know the problem. That is dumb. Fuck me. It only goes down one layer. Because this helper is wrapping arbitrary keys here, these sub-objects aren't being hit. Sad news, well, happy news, there's a solution that works, but it would require me to wrap every single one of these objects with a helper of some form. I can't just stub them out, which sucks. Also, if you do that wrapper, it seems to work in old versions too. So while I was hopeful this would fix my problem, and it's the same people, and they're relating to the same things here, no luck. RIP. I found the bad assumption that I didn't see before that made this not relevant to me. This is purely a difference between arrow functions and standard function definitions because standard function definitions rebind this, which they have to be sensitive to, which would cause it to type error more aggressively. I'm not getting what I want still. I'm sad. I was so excited here. For those who watched that whole journey, I am sorry. And for those who skipped it, welcome back. Let's talk about the next cool feature, subpath imports, starting with #/. When Node added support for modules, it added a feature called subpath imports, basically a field called imports, which allows packages to create internal aliases for modules within the package. You've all seen the pattern where you have like @ that references a specific thing. This is kind of like that, but part of the JS spec. Now TypeScript understands it better. This will let you use these custom defined paths instead of all of the ... that we all often end up doing. There are solutions for this that already exist, but they tend to not transpile well because what works for TypeScript's type checker might not work for the JS you ship, and you end up doing a lot of weird things with paths. This will help resolve a ton of that. Really cool to see. And that's what we're going to see a lot of, this alignment with other specs and standards, because specs and standards matter more than ever because that's what the LLMs are going to be using. They're simplifying module resolution keys. That's huge. Stable type ordering flag, which will assist from version 6 to 7 migrations. Today, TypeScript assigns type IDs, which are internal tracking numbers, to types in the order that they are encountered, and it uses those IDs to sort union types in a consistent manner. Similar process occurs for properties. As a result, the order in which things are declared in a program can have possibly surprising effects on things like declaration emit. So if you have an input here that will return condition $100 or 500, so if condition's true, we return 100. If it's false, we return 500. The output of this type that it has declared in the DTS is that this returns 100 or 500. But if you add a const of 500 above it, since the 500 occurs before the 100, it changes the order of the return type. That is a wild thing I never would have expected. This happens because the literal type 500 gets a lower type ID than 100 because it was processed first when analyzing the const x declaration. In very rare cases, this change in ordering can even cause errors to appear or disappear based on program processing order. But in general, the main place you might notice this ordering is in the emitted declaration files or in the way types are displayed in your editor. Oh, I can see where this gets problematic. One of the big things that the Go version allows is parallel type checking. But if the order of types changes because of what order you're checking them in, that breaks. So you need more deterministic ID assignment. And that's why they have this new stable type ordering flag so that TypeScript 6 will have the same order as 7. Note that we don't necessarily encourage using this flag all the time as it can add substantial slowdown to type checking, up to 25% depending on code bases. Okay, so this is a thing that is slower in one-shot TypeScript that does everything compiled start to finish. But in a parallel version, this will enable it to be stable, so that's a good thing. I see it now. That makes sense. Cool shit. ES 2025 options, cool, overdue. Types for temporal, fuck yes, we finally have temporal. It took long enough. New types for upsert methods, aka get or insert for maps. Nice. If you have a map, you want to do things or check things, it can be more strict. Very nice to see. Ooh, I forgot about this change. The regex standard now has a proposal for escape, which will auto-escape a string so you can pass it to a regex thing like this. And now they have it included and the type checks for it accordingly. Nice. The DOM lib now has DOM iterable and async iterable. Finally. Those are so useful. Then there's a pile of breaking changes here. This is actually an interesting call-out. In the 2 years since TypeScript 5, we've seen ongoing shifts in how devs write and ship JavaScript. First off, virtually every runtime is now evergreen. Truly legacy environments like ES5 are vanishingly rare. Yeah, all of the things you target are going to be targeted pretty consistently. Then we have the bundlers and ESM becoming more common module targets for new projects, though CommonJS still remains a major one as well, so they can't deprecate CommonJS, but bundlers and ESM need to be handled. AMD and other in-browser userland module systems are much rarer than they were in 2012. I would expect them to deprecate it. UMD packages still exist, but virtually no new code is available, only as a global variable. Yep. tsconfig.json is now universal as a configuration mechanism. Yep. Appetite for stricter typing continues to grow. Yep. These two play together very nicely, as we'll see soon. TypeScript build performance is top of mind. Despite the gains of TypeScript 7, performance must always remain a key goal, and options which can't be supported in a performant way need to be more strongly justified. You can ignore the things that TypeScript 6 deprecates, but in 7, you will not be able to get away with that because anything that 6 is deprecating will not work in 7 because they're deprecating it in 6 because they don't want to support it in the Go version. Fascinating. They call out that most projects will need to do at least one of these things, including setting the types array or setting a root directory if you were relying on it being inferred. I've had to deal with this so many times. And now we get to my favorite changes. Strict is finally true by default. This should have been a thing forever. Poor Matt Pocock had his recommended TypeScript config that basically everyone had to use as a starting point because things like this were missing. Module now defaults to ES Next, another great change. Target defaults to current year ES versions, another great change. No unchecked side effect imports is now true by default. This helps catch issues with typos and side effect only imports. Nice. This is if you're importing something that you're not using, it didn't used to actually check if it existed or not. Now it will by default. That's great. Lib replacement is now false by default. This flag previously incurred a large number of failed module resolutions for every run, which in turn increased the number of locations we needed to watch under the -- watch and editor scenarios. In a new project, lib replacement never does anything until other explicit configuration takes place, so it makes sense to turn it off by default. Good shit. Root dir now defaults to the current dir, period. Previously, we didn't specify one. It was inferred based on the common directory of all non-declaration input files. This often meant it was impossible to know if a file belonged to a project without trying to load and parse the project. Awesome. Now it just is the directory you're in. That's where it should be. Types now defaults to empty array. So if you're not adding things like node, which has types like fs in it, it's not going to include that by default. Makes a lot of sense. Good changes. If you want to have types for jest, you should include that as well. But having this be empty by default is a good thing. You can also do star, which will load all of those types of generic types that were in TypeScript. I love they even have cannot find name bun in here because you have to include those otherwise. Makes sense. They deprecated ES5. Finally, this was a pre-2015 standard. Deprecated down-level iteration, which was only for ES5. Makes sense. Module resolution deprecated. AMD, UMD, and System.js values of modules, good. Base URL being deprecated is very good. The better root path thing is significantly better. Yeah, no more base URL. Instead, you have root, and then you have custom paths that it handles much better now. Oh, there's a catch-all to replace base URL. Cool. That's a fun change. There's two strict modes. We have the strict TypeScript checker, but we also have JavaScript strict mode. And the JavaScript strict mode here was a thing you would have to tell TypeScript to not emit if you didn't want the output code to be in strict mode. Basically, everyone is shipping strict in JS now. Is just a better standard. And now they don't support it at all anymore. Cool. Good to see. Deprecated out file. The out file option has been removed from TypeScript 6. Interesting. Probably doesn't matter too much. Legacy module syntax for namespaces. Good. Namespace chaos was bad. Now you have to use the namespace keyword instead of module. Good to see. Still declare module if you have to. Interesting. The keywords on imports through asserts proposal got changed. So this asserts type JSON thing is no longer correct syntax. They moved to the with syntax. So that is not supported instead. Interesting. I didn't know this. And I'm assuming this is, again, like the changes they're making for agents. Did you know that if you run TSC on a specific file, it ignores your TS config? I didn't know that. That sucks really hard. That is now handled in TypeScript 6. Not by including the config, but by giving you an error that happened so that, I don't know, if an agent does this, it will see that it's not using your config. Dope. Great. Things like that. Like, this is the thing I really want to drive home here is the way the TypeScript team's thinking of TypeScript isn't what cool new features can we add? It's what error cases can we make clearer? How can we steer agents in the right direction? How can we make everything faster without breaking APIs? And what can we deprecate to make the size of everything simpler? All really good changes. And now for what we're all here for, the what's next. TypeScript 6 is feature stable, and we don't plan on any new features or breaking changes. Over the next few weeks, we'll be addressing any new issues reported on the 6.0 codebase, so we encourage you to leave feedback and report any issues that you encounter. And while the beta release is a great way to try out the next version of TS, we also publish nightly builds on NPM and in your editor, which are typically very stable. These releases can often give you a better snapshot of what issues have been fixed. We are also continuing to work on TypeScript 7. We publish nightly builds of our native previews along with a VS Code extension as well. Feedback on both 6 and 7 are much appreciated, and we encourage you to try out both if you can. It is kind of nuts that like they have been so transparent with the TypeScript native previews that you can just go install it in your code base and it works. They are getting more and more traffic. Obviously, official TypeScript still in the 120 plus mil downloads a week, but TypeScript Go is already over 2 mil. It's closing fast. In the very near future, these will flip. At the very least, not like in this chart to be clear, because people aren't going to start installing the @TypeScript/native preview thing that much. But what will change is that the default TypeScript will start being the 7 version, which is written in Go, and will be much faster for everyone. And the progress has been great. Even this update's already a little out of date, but they talk about all the crazy things that they've gotten working. The key pieces that you expect, like code completion, go to definition, go to type def, go to implementation, find all reference, rename, all the things you need in your editor in particular have been figured out, which is where you'll feel the benefits the most, I would argue. No more sitting there waiting for the type to resolve. You just click it and you go. It's great. It also means agents will get feedback through the LSP significantly faster. Interesting. Things like the watch flag are less efficient than the existing TypeScript version for some scenarios. It's probably where a lot of the memory leaks I'm seeing are coming from. They also call it here, they don't intend to do a TypeScript 6.1. They might have to do patch releases under other circumstances, but TypeScript 6.0 is very much meant to be that incremental release to help people get ready for TypeScript 7. All really good stuff to hear. I am super hyped. Not only is this great for TypeScript developers, I would argue that what the TypeScript team is doing is a great model for other open source projects to follow. In a world where agents are writing more and more of our code, code, we should be thinking less about how we're going to change our APIs and add a bunch of new features and syntax, and more about how we can give the best possible context in the shortest possible time to the agents that we're running. I know this isn't an AI video, but in the end, a lot of this directional shift is because of AI and the power and how it enables us to write code. I personally believe that TypeScript is the best possible language for AI, and things like this are making it even better. I am so excited to keep building with TypeScript, and I hope you guys are too. Let me know what y'all think, and until next time, peace nerds.